partial differentiation. Here we consider the function u is in terms of x and y. Sometime we may have u as in terms of x. See, we have studied in the lower semester y equal to f of x. So here f of x means we may have exponential function, or we may have sine x trigonometric function, or we may have algebraic term, polynomial, or any other form of combination of any of these terms. So here y is f of x means we have only x term in the right hand side. E power x, sin x, cos x, tan x, secant square x, or x cube plus x square, like this. So here right hand side we have only one variable. We are differentiating y with respect to x. Right hand side only one term is there. We are differentiating with respect to x. So this one is nothing but f dash of x. That means we are differentiating this one with respect to x. But here we have two variables, that is u equal to f of x comma y. That means we can differentiate with respect to x or with respect to y. We cannot differentiate x and y together. So here we cannot differentiate x and y together. So here during differentiation partially, okay, so here differentiation partially with respect to, suppose if we write x, then this u we can write it as dou u by dou x. We call it as dou u by dou x equal to dou by dou x of f of x comma. So here differentiate partially. Remember, we are using the word partially with respect to y. So when we are differentiating with respect to y, so here f of x and y is there. So here x is constant. So we write it this as dou u by dou y equal to dou by dou y of f of x comma y. So here we do some of the problems for understanding. Before that, we remember some of the terms. So here we are differentiating with respect to x partially. We write it this as dou u by dou x is nothing but p. Dou u by dou y is nothing but q. Dou square u by dou x square is r. Dou square u by dou x into dou y is nothing but s. T is nothing but dou square u by dou y square. Dou u by dou x, we can write it as differentiation of u with respect to x partially. So we can write it like this also. Dou u by dou y is nothing but u with respect to y. Dou square u dividing by dou x square is nothing but u is differentiated 2 times. Dou square u dividing by dou x into dou y, we can write it as u with respect to y and x. Dou square u dividing by dou y square is nothing but u y y. Discuss the problems. So here let us consider the function u equal to x square plus y square. So here right hand side we have x and y. We must find out dou u by dou x. and dou u by dou y. So right hand side x square plus y square is there. We differentiate. Say here differentiate u with respect to x partially. So we have the another term y is constant. Y is constant. So here I am writing ux. Differentiation of u with respect to x partially ux or dou u by dou x. Now here I am differentiating x square. X square is 2x. Remember, while differentiating with respect to y, here sorry y square with respect to x, here y is constant, differentiation become 0. Now differentiate u with respect to x once again here instead of partially. Okay, so here y is constant. So here u with respect to x once again is nothing but differentiate. So here differentiate ux with respect to x. So here if we differentiate ux is nothing but if we differentiate we get uxx. So here right hand side 2x is there. We have only x term. So differentiation of x is 1. We get 2. Now u is x square plus y square. So I am differentiating u with respect to y. Here x is constant. So here if we differentiate with respect to y, so x is constant. So remember this one, x differentiate constant differentiation is 0 plus y square is 2y. So differentiate uy with respect to y. So here x is constant. So u y is nothing but we are differentiating this 2y will be 2. So here we consider the function u equal to x cube plus y cube plus 3axy. So here I am differentiating with respect to x partially, y is constant, x cube differentiation is 3x square, y is constant, remember y is constant here, x cube y cube becomes 0 plus here 3ay is constant. We must differentiate only with respect to x is 1. So here I am differentiating ux with respect to x. So u is differentiated 2 times. Here 3x square can be written as 6x plus already 0 is there, need not repeat, plus here 3ay, y is constant. While differentiating with respect to x, y is constant, this becomes 0. So we get 6x. Here u is differentiated with respect to y. So here partially x is constant. So here uy equal to, so here x is constant, so x cube is 0 plus y cube is 3y square plus here constant term we write it first 3ax into y is 1. So answer is 3y square plus 3ax. So here if we differentiate once again with respect to y, 3y square we can write it as 6 into y plus 3ax is 0. Why? Because all the terms are constant. So answer is 6y. So here we can find out ux differentiate with respect to y. So if we write this one, this is nothing but dou u by dou x is differentiated with respect to y. We write it this as u y x. So here u y x. So here first u x. What is u x? U x is nothing but this one. So here this one differentiate with respect to y, 3x square plus 3ay. So here we are expressing the symbol dou, so that should be remembered. If we differentiate with respect to y, so x is constant, 0 plus 3a into y differentiation is 1. Answer is 3a. Now, so I am writing three functions u, x plus y plus z. So v is x into y into z. We understand these two concepts. First we learn the basic concept. So here I am differentiating u with respect to x partially. I must differentiate only x. So x is 1 plus y differentiation 0 plus z differentiation is 0. Understand this one? U y. I am differentiating only y here. All other terms are constant. X is constant, z is constant, x is constant 0 plus y is 1 plus z is constant 0. Now differentiation with respect to z. So here x is constant 0, y is constant 0, z is 1. So here sometime if we write the term as it is, it will be good. So here I am writing here differentiate v with respect to x. So when we are differentiating with respect to x, y, z are constant. So understand this one. I am differentiating with respect to x, y, z are constant. So y into z is constant. So we write it y into z. X differentiation is 1. Very important. Understand this type of problems. Now I am differentiating v with respect to y. So when we are differentiating with respect to y, x and z are constant. So here vy equal to, here multiplication is there. So x and z are constant into y differentiation is 1. The same concept we are applying here also. Now we differentiated with respect to z. X into y, z differentiation is 1. Here let us consider u is x into y plus y into z plus z into x. Similarly, I am considering u equal to x square into y into z plus y into z square. So these both are different problems. I am differentiating u differentiating u with respect to x. So here when we are differentiating with respect to x, y, z are constant. So ux equal to, so here x into y is there, y is constant, x differentiation is 1. So here 1 into y plus y into z is nothing but constant. So here 0 plus x differentiation is 1 into constant z. So here we are getting y plus z. Now differentiation with respect to y. So here when we are differentiating with respect to y, x and z are constant. So here x constant, we write it as it is, y differentiation is 1 plus y differentiation is 1 into z plus, here we don't have y, then it is 0. So here we are having x plus z. Now differentiate u with respect to z. See here, first term we do not have z here, x into y is there, we get 0 plus here y into z, y is constant, z differentiation is 1 plus z is 1 into x. So here we can write it as x plus y or y plus x. See the next problem. This one differentiated with respect to x. Here x square is nothing but 2x into y into z plus, here we do not have x term, we get 0. U with respect to y. You can see first term also we have y, second term also we have y. We must differentiate both the term. Here x and z are constant, so x square into z, we write it as it is first. Differentiation of y is 1 plus, here y differentiation is 1 into z square. U differentiated with respect to z. So here x square into y is constant into z, z differentiation is 1 plus, here y into z differentiation is nothing but 2z. Answer is x square y plus 2 into y into z. Consider the trigonometric function u equal to sine of x into y. So here I am differentiating with respect to x. Ux, understand, sine differentiation is cos of x into y, we must write as it is. After writing this one, we must differentiate dou by dou x, the function x into y. So here cos of xy into, if we differentiate with respect to x, x become 1, y is constant. So here this is nothing but ordinary differentiation of sine 2x with respect to x. So what we used to do, first we are differentiating sine 2x. So sine is nothing but cos 2x. Then we are differentiating 2x once again. So here if we differentiate, we get 2 times cos 2x. The same things we are applying here. Here instead of, here we are getting 2 as constant. Here instead of 2 we have y as constant. So here I am differentiating u with respect to y. Sine differentiation is cos of x y. So here x into y is differentiated with respect to y. So x is constant. So x, we write it as it is, cos of xy. Then differentiation with respect to y is 1 here. So here we have differentiated u with respect to x only once and y with respect to y only once. Here I am differentiate ux with respect to y. Understand? I am differentiating ux with respect to y. This is nothing but uyx. So here we have y term cos of xy. Here also y is there. We must apply the product rule. So here cos of xy into y is 1. Y differentiation is 1 plus y into differentiation of cos is minus sine of xy. Then differentiation of xy with respect to y is x. So we are getting the answer cos of xy minus xy into sine of xy. So we must practice this one so that we can understand the problem easily. So we discussed the last one, u equal to e power ax minus by. So here ux differentiation with respect to x partially, exponential term is there, so e power x differentiation of e power x is e power x. So first we write as it is, e power ax plus by. Now we differentiate a power ax plus by. So we get e power ax plus by. Here ax differentiation is a plus by is 0. Because we are differentiating with respect to x partially, y is 0. Remember, we must remember that d by dx of y is y1, but dou by dou x of y is 0. So we must, while doing the problem, this concept we must remember. Similarly, if we differentiate with respect to y, first we write the exponential term e power ax plus by, then differentiation of the power ax plus by. So here we get e power ax plus by, then differentiation of this one, ax is 0 with respect to y plus b.